Hi everyone, in this video we will learn about valence electrons. Although I've mentioned this term earlier on in my earlier videos, but once again, valence electrons are the electrons in the outermost energy level. So if this is a nucleus and you have first energy level, second energy level, or third energy level, then this is the outermost energy level. So this is called valence shell, and any electron that is sitting in this energy level are called valence electrons. So all of the chemical properties depend how many valence electrons any element has, because this is where it decides whether it's going to gain electrons or lose electrons. And based on the gaining and losing of electrons, it's going to be cation, anion, oxidation, reduction, who is it going to react with. So all of the chemical behavior depends on the valence electrons. This is very important concept. So since all the chemical properties depend on the valence electrons, there was a scientist, his name was Lewis. He said, why not we count the valence electrons and show them as a dot around the symbol, and that is called electron dot structure. So let's do the electronic configuration of lithium. 3 electrons, 1s2, 2s1. So how many valence electrons it has? Lithium, 1s2 means first energy level, and it has 2 electrons in it. And then 2 means second energy level, and it has 1 electron in it. So this is valence shell, and this is valence electrons. That means this is the outermost energy level. You're looking for the biggest number here, the coefficient, and this is how many electrons it has. So this is valence shell, and these are valence electrons. So lithium has 1 valence electron. So what I'm going to do is I'll say lithium and I say 1 dot on lithium. So this is called the dot diagram of lithium. Okay, let's do carbon. Carbon has 6 total electrons. So I do 1s2, 2s2, and 2p2. So how many valence electrons carbon has again? This is a second energy level. You're looking for the biggest number, 1 and then 2, and then I'm going to add them together. So carbon has 4 valence electrons in the second energy level. Okay, so this is valence shell, and these are the valence electrons. So I'm going to draw carbon, and 1, 2, 3, 4. It doesn't matter which way you go, where you start from. You go clockwise, counterclockwise, doesn't matter. But what matters is you don't want to sprinkle them around. Alright, so you have to go in 4 corners. So let's do boron. Boron has 5 total electron. Atomic number is 5. So the electronic configuration is 1s2, 2s2, and 2p1. So how many valence electrons? 3. So I draw boron. I go 1, 2, and 3. So this is a dot diagram of boron. So you can do the valence electrons by looking at the electronic configuration, see which one is the biggest number. Like I was doing the electronic configuration for iron. Iron has 26. So you go 1s2, 2s2, 2p6, 3s2, 2p6, 4s2, 3d6. So which one is the biggest number in electron in this? Which one is the biggest energy level? So 4 is the biggest energy level. That is the outermost energy level. And how many electrons in there? 2. So I will do iron, and I will say 2. Or you can do iron like this, or you can do iron like this. It doesn't matter. But the reason it is I am drawing them together because they are both in the S sublevel. So sublevel S means S takes 1 orbital, and they're both paired together. So that's why this is a better, technically better answer compared to this. But if this is the only option you are given, then this could be the right answer. But between these two, between A and B, if you have the option of A and B, B is a better choice for the dot diagram of iron. All right, so I'm sorry I had an interruption. So what I was saying that we have iron. I was doing the dot diagram of iron. So S has two electrons together. So technically, iron dot diagram is better because 2 electrons are together. But this is not a wrong answer as well if this is the only option you're given. because iron will have only 2 valence electrons. So this is one way of doing the dot diagram, where you are given the electronic configuration, you see how many, which one is the valence shell and how many valence electrons it has. The easy way to do the dot diagram is you look at the periodic table. Okay, so when you look at the periodic table, you see group numbers, group number 1, 2, 3 to 12, and then you have 13, 14, 15, 16, 17, and 18. So everybody in that same group has same number of valence electrons. I hope you understand what I just said. That everybody in group 1 have 1 valence electron, whether it is lithium or it is francium here. Okay, the dot diagram is going to be lithium, sodium, potassium, rubidium, cesium, francium. Only one valence electron. Everybody in group 2 has 2 valence electrons. So whether it is beryllium or it is radium, okay, they will have 2 valence electrons. Everybody here has 3, 4, 5, 6, 7, and 8 valence electrons. So everyone in group 17, for example, fluorine, bromine, iodine, they have 7 valence electrons. You have fluorine to acetine actually. Everybody has 7 valence electrons. You go 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. 5, 6, 7. So everybody has 7 valence electrons. So this is very easy. This rule does not apply for the elements here. For this, you have to do the electronic configuration and do the valence electrons as I taught you before. You have to do the electronic configuration like we did for iron, find out which one is the valence shell, and then see how many electrons are there. So this is what you have to do for transition metals. But for everybody else, you don't have to do the electronic configuration. You just have to see where the element is located. Then whichever group number it's in, it goes by the last digit. So 3, 4, 5, 6, 7, 8. So since, as I was telling you, that all the valence electrons decide the chemical behavior. Okay, this is why we say that all elements in one group have similar chemical behavior, because they have same number of valence electrons. So we talked about families and groups and periods, and we said that all elements in one group behaves the same chemically, and that is because of their valence electrons. So you need to learn how to find out valence electrons, how to do the dot diagram from the periodic table, which is so easy, or from the electronic configuration, which we just learned earlier on. So that's all you need to know on valence electrons. You need to do all these practice questions and get ready for chapter 5 quiz. This is all about chapter 5, and next class you will have a quiz on chapter 5, or just follow your pacing guide. It isn't, not really next class. Just follow your pacing guide. All right, thank you.